matrix. Then it says given an n by n matrix, return all the elements of matrix in spiral order. So right here we have 1, 2, 3, 6, 9, 8, 7, 4, 5. So we're returning it in a spiral order, meaning a circular order, right? So it's going to be 1, 2, 3, then 6, 9, 8, 7, 4, 5. So we're returning it like this. And how are we going to solve this question? It's similar with example 2, right? 1, 2, 3, 4, 8, 12, 11, 10, 9, 5, 6, 7. So we're doing it in a spiral order. So how we're going to solve this, we're going to create a variable direction, maintain the variable direction, and the direction will indicate the direction that we need to travel in. It will store the value of either 1 or -1, and this value will be changed based on the following rules. So it will be 1 if we're traveling in from left to right, and 1 if we're traveling from top to bottom. So direction is going to be 1 if we're traveling from left to right or top to bottom, and it will be -1 if we're traveling from right to left, right? So from right to left or from bottom to top, okay? From bottom to top. So that is how the algorithm is going to go. We're first going to initialize rows and columns variable. So I'm going to say rows, comma, columns is equal to the length of the matrix and the length of the matrix. Then after that, we're going to initialize row and column, and so row and column is going to be used to traverse the matrix. So we're going to say row, comma, column is equal to 0, comma, -1. Then we're going to have the direction variable, and the direction variable is going to help us to know how we're going to be moving through the matrix, the multidimensional array. So direction is going to be equal to 1 here, and this is just indicating the direction which we're going to travel in, right? It's initialized to 1 because if you remember, I said that from left to right our traversal is going to be 1, but when we are going right to left it's going to be -1. So that's why it's 1 for now. Then after that, we have our result array, which is what we're going to be using to return things. It's going to be an empty array. So for now we're going to say while rows is greater than 0 and columns is greater than 0, what we're going to do, we're going to loop through. So we're going to say for this in range columns, we want to be changing the direction. So we're going to traverse from left to right in a row by adding the direction variable to column, while keeping the value of row unchanged. In each iteration, we will add matrix row column to results. At the end of this row traversal, we will decrement rows by 1, because if we traverse a column after this, we will traverse 1 less elements. So we're going to be adding direction to column. So column plus equals to direction, and we're going to be appending it into our results array. Dot append matrix row and then column. Oh sorry, it's only meant to be call because that is how I initialize my variable. And then we're going to then decrement 1 row because we don't want it to be 1 less. Now we're going to do the same thing, but this time we're going to do it for rows. So in rows, we're going to travel from top to bottom in a column by adding the direction variable to row, while keeping the value of column unchanged. At each iteration, we will add matrix row column to results. At the end of the column traversal, we will decrement columns. So similar things, we're just going to loop through this. So say for in range rows, and we are going to say row plus equal to direction, and then we're going to be appending it to the result array matrix row and then column, and then we're going to remove it, cos minus equal to 1. Okay, and if you remember, do you remember why we subtracted by 1? We decrement the columns simply because if we traverse a row after this, we'll traverse one less element, and we don't want that to happen. And we're going to be, so to move from right to left or bottom to top, we're going to be multiplying it by -1, the direction variable by -1, which is what we're going to be doing here, because we also want to move from right to left. So it's going to be direction times equals -1. Okay, and we're also going to return the result outside the while loop. Return result. So let's try running this. Okay, there's an unmatched column, line 16. Okay, so oh yes, this is not meant to be here. Oh, I kept saying column, sorry. I initialize it as call. What did you say? List index is out of range. That's strange. Result dot append matrix row column. Pause this. Rows. Rows is greater than 0 and column is greater than 0. Range calls. And then for this in range rows, okay. Row plus equals to direction. Row result dot append matrix row column. Okay. Columns -1. This is meant to work. So let's look back at what we did, okay? So the first thing we do, we calculate the number of rows and columns. So our rows is the length of our matrix, our columns is the length of each column and the column. Then we have pointers to traverse the matrix, which is row and column. Row is set to 0, column is set to -1. Then our direction is set to 1, which is our initial direction, moving from left to right. Then we create a result array to store the elements in a spiral order. Now we're saying while rows is greater than 0 and columns is greater than 0, right? Once you start traversing it, we want to move horizontally or in one or two directions. So if it's left to right, direction is going to be equal to 1. If it's right to left, we're also going to direction is going to be -1, and we're going to be incrementing the call pointer to move horizontally. So now we are looping through columns, and we're saying columns plus equal to direction. Results dot append row call. Okay, now we're decrementing row, not rows. We're decrementing rows. I think that's a mistake I made, because you don't want to start getting one less. Then after that, we are doing the same thing for columns. So remember, top to bottom is direction is going to be 1, bottom to top is going to be -1. So for this, in range rows, we're going to be moving forward with direction, and we're going to be appending this. I'm going to say cos minus equals to 1. Let's see. Yeah, cos minus equals to 1, because you want to increment the row pointer and move vertically. Okay, and then we're going to be flipping the direction for the next traversal and return results. Okay, so now I walk through. So sometimes when you don't know why it's not working, you can always go back to your solution and study more. So the time complexity of this solution is O of m times n, because each cell of the matrix is traversed. While the space complexity is O of 1, because we didn't use any extra space. Right. Thank you so much for watching today.